Hello, very welcome to everyone to my presentation video of my CA1 assignment, that is on the subject Mobile Communication and Networks. I am Diyasha Chaudhary and I am from the Department of Electronics and Communication Engineering. So this is my assignment of Mobile Communication and Networks. Thank you to Saurabh Chakraborty sir for giving me the opportunity to present this presentation. Let's move on to the next page. So, what is mobile communication and networks? This is the introduction page. The field of mobile communication has undergone a remarkable transformation for the past few decades, from the early days of analog cellular networks to the current high-speed 5G technology. The evolution of mobile networks has revolutionized the way we communicate, access information, and stay connected. This presentation will provide a comprehensive overview of the key components, technologies, and emerging trends that have shaped the mobile communication landscape with a focus on understanding the fundamental principles and functionalities that enable seamless and efficient wireless communication. Here we have the cell structure, that is the components and functionality. Number one is the cell site. The fundamental building block of a mobile network is a cell site, which consists of a base station and an antenna system. The base station is responsible for managing and coordinating the wireless communication within the cell, while the antenna transmits and receives the radio signals to and from mobile devices. What is cell coverage? Cells are designed to provide seamless coverage across a geographical area, with each cell overlapping with its neighboring cells. This overlapping coverage ensures that mobile devices can maintain a continuous connection as they move between cells, enabling uninterrupted communication and handoff between calls. Next up, we have cell types. Mobile networks employ different types of cells, such as macro cells, micro cells, and picocells, to address the verifying needs of urban, suburban, and indoor environments. Each cell type has its own characteristic and is optimized to provide the best possible coverage and capacity based on the specific requirements of the deployment area. Here we have the frequency reuse efficient spectrum utilization. The concept of frequency reuse is based on a, a technique that allows the same frequency bands to be used in multiple non-overlapping cells. Then we have the reuse distance. The reuse distance is the distance between cells using the same frequency band, that is a critical factor in frequency reuse. And lastly, the frequency reuse patterns. So mobile networks employ various frequency reuse patterns such as the 7 cell and 12 cell reuse patterns to achieve the optimal balance between coverage, capacity, and interference. Here we have the cell splitting, which is increasing capacity. It is of three types. Number one is capacity constraints. Number of mobile users and the demand of data intensive applications are continuing to grow. Mobile networks face the challenge of meeting the increasing capacity requirements. This is why conventional cell structures may become insufficient to handle the ever increasing traffic load. Cell splitting concept. Cell splitting is a technique used to increase the capacity of a mobile network by subdividing a larger cell into smaller cells, each with its own base station and coverage area. And what are the benefits of the cell splitting concept? Not only increases the overall capacity of the network, but it also enhances coverage, reduces interference, and improves the quality of service experienced by mobile users. Channel assignment techniques and strategies. Here we have two techniques and strategies, namely number one is fixed channel allocation, number two is dynamic channel allocation, number three is hybrid channel allocation, and number four is channel warping. Here we have the hands-off seamless connectivity. Handoff initiation. As a mobile device moves within the coverage area of a mobile network, it may need to switch its connection from one cell to another, a process known as handoff. And what are its types? There are different types of handoffs, including hard handoff, soft handoff, and seamless handoff. Choice of handoff technique depends on factors such as the network architecture, signal strength, and mobile devices capacity, ensuring a smooth transition between cells. And handoff management. Effective handoff management is crucial for maintaining uninterrupted communication and a high quality user experience. Okay, now we have interference, source and mitigation. Types of interference are: interference is a critical challenge in mobile communication as it can degrade the quality of wireless signal and disrupt the overall network performance. Mobile networks face various types of interference, including co-channel interference, adjacent channel interference, and intercell interference, which with its own unique characteristics and mitigation strategies. Interference mitigation techniques. Mobile networks enjoy a range of techniques to mitigate interference such as power control, sectorization, frequency planning, and advanced signal processing algorithms. These techniques help to minimize the impact of interference, improve the signal to noise ratio, and ensure reliable and high quality communication within the network. Emerging approaches. With the continued evolution of mobile communication technologies, new approaches to interference mitigation are being developed, such as the use of beamforming, cognitive radio, and interference cancellation techniques. These advanced methods aim to further enhance the overall performance and efficiency of mobile networks in the face of increasing interference challenge. Power control. We can power control by battery life, network capacity, signal quality, and interference reduction. Power control is crucial for optimizing the energy efficiency of mobile devices as it helps to extend the battery life by minimizing the power consumption required for wireless communication. Signal quality. Effective power control ensures that mobile devices transmit at the minimum power required to maintain a reliable connection. Network capacity. By controlling the power levels of mobile devices, mobile networks can maximize the overall capacity and efficiency of the system, allowing more users to be served with the available resources. Power control plays a crucial role in mitigating interference by ensuring that mobile devices transmit at the appropriate power levels. Emerging trends in mobile networks, 5G and beyond. Then we have software-defined networking, and finally we have edge computing. And finally, the conclusion is evolving landscape. The mobile communication landscape has undergone remarkable advancements driven by innovative technologies and the ever-growing demand for seamless connectivity and high-speed data access. Ongoing challenges. Addressing challenges like interference, capacity constraints, and energy efficiency remains a critical focus area in the continuous development of mobile networks, with emerging technologies and strategies playing a key role in overcoming these obstacles. Foundational principles. Understanding the fundamental principles of mobile networks such as cell structure, frequency reuse, channel assignment, and power control is crucial for designing and optimizing efficient and reliable wireless communication systems. And lastly, future directions. The future of mobile communication promises even greater advancement. With the widespread adoption of 5G, the integration of edge computing, and the evolution of software-defined networking technologies transforming the way we connect, communicate, and interact with the digital world. Thank you so much.